Hey everyone, and welcome back for another deep dive.
I always love these deep dives.
Me too.
Yeah.
It's so great to just, take some time and really dig into a topic.
Absolutely.
So today we're heading over to India,
Oh, cool. Where are we going in India?
the Institute of Technology, Mumbai.
Oh, wow. Okay.
Yeah.
Yeah.
We're going to be sitting in on a lecture with Professor Pushpito Ghosh. He teaches a course called Renewable Energy Resources.
I like it already.
Right. So it's GTT 2105 if you want to look it up. The lecture we're looking at is from the 2021-2022 session.
Okay.
And lucky for us, someone uploaded the whole thing to YouTube just last year, so.
Awesome. I love when that happens. I mean, knowledge should be free, right?
Totally agree. Anyway, this lecture is actually a follow-up to the first one in the course.
Okay, so like building on what he talked about before.
Exactly.
Mhm.
So Professor Ghosh kind of starts off reminding everyone why renewable energy is such a, like a vital thing to be talking about right now.
Right, right. Everyone's talking about it, but why?
Well, on the one hand, you've got fossil fuels like dwindling.
Which we're completely dependent on, or at least we have been.
Yeah, and then at the same time, because we're burning all those fossil fuels.
CO2 emissions are going way up.
You got it.
Yeah.
And Professor Ghosh actually shows the data on how much CO2 has increased in the atmosphere since the Industrial Revolution.
And I'm guessing it's a lot.
Oh, it's a lot. Like you
yeah.
can really see it on the graph. It's pretty dramatic.
And we talk a lot about how fast things are changing now, so I bet that increase has really sped up lately, right?
You are so right. Professor Ghosh actually points out that half of the total increase has happened just since 1980.
Whoa, wait a minute. Half of all the extra CO2 since like the 1800s has been added in just the last, 40 years?
That's exactly what he said.
Yeah.
Like, think about it. We went from those pre-industrial levels up to where we are now, and half of that jump has happened just in our lifetimes, basically.
That's mind-blowing.
Right. And it's not like this is just a guess or anything. They have ice core samples going back thousands of years and more recent data from monitoring stations, like the one in Hawaii.
Okay, so we're talking solid scientific data.
Absolutely. But hold on. This is where it gets even crazier.
Okay, lay it on me.
So Professor Ghosh takes it a step further.
Even further.
Yeah. He actually calculates the total weight of all that extra CO2 that's in the atmosphere.
Whoa, whoa, whoa. The weight. Like how much it would weigh if you could put it all on a scale.
That's exactly what he does. And I was like, how's that even possible?
Right? Like how do you even begin to calculate something like that?
It's actually pretty straightforward. Like he starts with this basic fact. A column of air that's 1 square centimeter wide, so like super tiny, from sea level all the way to the edge of space.
Okay, I'm picturing it.
So that column of air, it weighs about 1 kilogram.
Okay, 1 kilogram.
So then you just scale that up.
Scale it up.
Yeah.
Yeah.
And multiply that 1 kilogram by the Earth's total surface area.
Oh, wow, I see. So now you have the weight of the whole atmosphere.
You got it. But then you have to factor in the concentration of CO2.
Right, because it's not all CO2, it's just a part of the air.
And we measure that in parts per million, or ppm.
Okay, so you take that massive weight of the atmosphere and you calculate what percentage of that is just pure CO2. That's so clever.
I know, right? So, are you ready for the final answer?
Oh, I'm on the edge of my seat here.
It's 3,209 billion tons of CO2.
3 trillion tons. That's like, I don't even know, carrying around a small moon or something.
Right. It really gives you a sense of the scale of the problem.
No wonder everyone's so concerned.
Yeah, and Professor Ghosh is really clear about connecting this CO2 surge to, you guessed it, burning fossil fuels.
Yeah, that makes sense. I mean, that's what we've been doing for centuries, burning coal and oil and gas.
Exactly. And he has all this evidence to back it up.
Like what kind of evidence?
Well, one thing he points to is that oxygen levels in the atmosphere are actually going down.
Oh, right, because when we burn fossil fuels, we're using up oxygen, duh, like a giant fire.
Exactly. It's like this massive chemical reaction happening all over the planet.
Wow. So what other clues are there?
So there's this thing called carbon-14. It's a radioactive isotope of carbon.
Okay, I vaguely remember isotopes from high school chemistry.
So this carbon-14 is naturally found in the atmosphere.
Gotcha.
But here's the thing. Fossil fuels don't have any carbon-14 in them.
So the thinking is, if we're burning all these fossil fuels, there should be less and less carbon-14 in the atmosphere.
You got it.
Yeah.
And the data actually shows that's exactly what's happening.
That's pretty convincing. Like a fingerprint pointing right to fossil fuels.
I know. It's like science is solving a mystery.
It really is. But I'm guessing this CO2 increase isn't happening evenly everywhere on Earth, right?
You are so sharp. Professor Ghosh actually brings this up. He shows how the increase is way more pronounced in the northern hemisphere.
Which is where most of the industrialized countries are, right?
Exactly. It's like all the factories and cars, and power plants are concentrated there.
Right. And it really makes you think, like even if one country cuts back on emissions, it's still a global issue.
It is a global issue, for sure. But you know what's really interesting? The Earth actually has some natural defenses.
Defenses, like an immune system.
Kind of. He calls them carbon sinks.
Carbon sinks.
Yeah, basically these are natural reservoirs that absorb CO2 from the atmosphere.
I see.
And the oceans are like the biggest players here.
Really? So the oceans are like soaking up CO2.
They're like giant sponges sucking it all up. Land and soil also play a role.
Oh, okay.
But the oceans are like the main event. And there's this whole thing called the carbon cycle, which is like this constant back and forth of CO2 between the atmosphere, the oceans, and land.
It's like a delicate dance.
It is. And then, to make things even more complicated, there's El Nino.
Oh, yeah. El Nino. I know that one.
I knew you'd be familiar. So El Nino, it messes with the Pacific Ocean, right? Like the currents and stuff.
Yeah, it makes the surface water warmer, I think.
Exactly. It weakens those trade winds, and that leads to warmer water.
Uh-huh. And warmer water holds less dissolved gas, right?
You are on fire today. So during El Nino, the Pacific Ocean actually releases more CO2 into the atmosphere.
Wow. So it's like this natural cycle, but then we humans come along and mess everything up.
It really makes you appreciate how interconnected everything is, right?
Absolutely. And I'm guessing all our human activities aren't helping this delicate balance.
Definitely not. I mean, just think about deforestation.
Yeah. Like cutting down all those trees that would normally be absorbing CO2.
And then there's cement production. Did you know that's a big CO2 contributor too?
Cement. Really? Yeah.
Making cement involves heating up limestone, and that releases a bunch of CO2.
So it's like even beyond burning fossil fuels, there are all these ways we're adding to the problem.
Yeah, and it's a lot for the Earth to handle. Professor Ghosh actually points out that there's this gap between how much CO2 we're releasing and how much the Earth can actually absorb.
Oh, no. So it's like we're overloading the system.
That's exactly it. And that's why all that extra CO2 is building up in the atmosphere year after year.
Man, that's heavy.
It is heavy.
It's one thing to talk about these problems like rising CO2 levels.
Right.
But it's another thing entirely to actually do something about it.
Totally. Like, how do we actually capture and use all that CO2?
Exactly. And that's what I really appreciate about Professor Ghosh's lecture.
Yeah.
He doesn't just dwell on the doom and gloom.
Yeah.
He actually presents some really cool ideas for solutions.
Okay, I am so ready for some solutions right now.
Well, get this. Remember we were talking about that supercritical CO2 stuff?
Yeah, for oil recovery.
Exactly. It's like straight out of science fiction.
It kind of is. Like using CO2 to get more oil.
I know, right? It seems so counterintuitive, but it actually works.
Okay, but remind me again. How does it actually work? All that supercritical fluid talk kind of went over my head.
No worries. I felt the same way. But the way Professor Ghosh explains it, it's like this. Imagine taking CO2 and squeezing it and heating it up.
Okay.
So much that it becomes this weird state of matter where it's both a liquid and a gas at the same time.
Okay, so that's the supercritical part.
You got it. And the supercritical CO2, it turns out, is really good at dissolving oil.
Really?
Yeah. So they pump it down into those oil wells and it basically loosens up all that thick, gooey oil that's stuck down there.
So it's like a CO2 power wash for oil wells.
Exactly. And not only that, some of that CO2 actually gets trapped underground.
Oh, wow. So it's like double duty, getting more oil A&D, reducing CO2 in the atmosphere.
Yeah. But of course, it's not a perfect solution.
I figured there had to be a catch.
Well, you have to think about the energy it takes to capture and pressurize all that CO2 in the first place.
Right, right. So it's not completely carbon neutral or anything.
Exactly. But still, it's a pretty amazing technology. And it's not the only one. Professor Ghosh had this other example that I thought was so cool, using CO2 to make styrofoam.
Wait, what? Styrofoam?
Yeah.
Like those takeout containers?
Yep, those ones. They used to make styrofoam with CFCs.
Oh, yeah, CFCs. The ozone layer killers.
Exactly. But someone figured out how to replace those CFCs with CO2 as the blowing agent.
A blowing agent, what's that?
It's what creates all those tiny bubbles in the styrofoam.
Oh. So they're taking CO2 and turning it into this everyday product.
Yep. It's a great example of what they call green chemistry.
I love that. It's like taking something harmful and turning it into something useful.
And it gets even better. Professor Ghosh talks about some larger scale projects that are using CO2 to make carbonate.
Carbonate. Like what exactly?
Well, think limestone.
Okay.
They're basically mimicking a natural process that already happens in the ocean where CO2 gets turned into carbonates, but they're finding ways to speed it up.
Oh, wow. So it's like fast-forwarding nature's own carbon storage mechanism.
Right. And then there are companies exploring ways to use CO2 to make polycarbonates.
Ollie, what now?
Polycarbonates. They're really strong plastics, like those clear cases that DVDs come in.
Oh, yeah. Those are super durable.
Yeah. So instead of releasing CO2 into the atmosphere, they're using it to create these really valuable materials.
Okay, I'm seeing a theme here. We can use CO2 for oil recovery, for making plastics, for actually storing carbon.
Exactly. It's like we're finally starting to get creative with how we deal with this problem.
I love it. What else did Professor Ghosh talk about?
Well, he also highlighted some industrial processes that have been using CO2 for a long time, maybe even centuries.
Oh, really?
Yeah.
Like what?
One example is the solvay process, which is used to make baking soda.
Wait a minute. Baking soda? Like the stuff I use in my kitchen?
The very same. It's a really clever process that uses limestone, salt, and ammonia to produce baking soda.
Okay.
And CO2 is a key part of that process.
So they're capturing CO2 and using it to make something that almost everyone uses. That's so cool.
I know, right? It's like this everyday product has a secret connection to climate change solutions.
Never going to look at baking soda the same way again. What else?
Another example is the Haber-Bosch process. It's how we make synthetic ammonia, which is a key ingredient in fertilizers. But the Haber-Bosch process, it's a bit of a mixed bag.
How so?
Well, on the one hand, it's allowed us to feed billions of people around the world. But on the other hand, it's a huge energy hog, and it produces a lot of CO2.
Oh, no. So it's like we need it, but it's also contributing to the problem.
Right. But here's the cool part. Chemists have figured out a way to use the CO2 that's produced as a byproduct of the Haber-Bosch process.
Ooh, I like where this is going.
They react it with ammonia to create urea, which is another type of fertilizer.
So it's like closing the loop. Instead of releasing that CO2, they're using it to make something beneficial.
Exactly. It's another example of how we can find creative ways to utilize CO2 and reduce our impact on the environment.
This is all so fascinating. I'm starting to see that there really are solutions out there. We just have to be willing to invest in them.
And to think outside the box. Professor Ghosh is really challenging us to look at CO2 not just as a problem, but as a potential resource.
It's like a whole new perspective on the climate crisis.
It really is. And it gives me hope that we can find a way to create a more sustainable future.
Me too. It's clear that we have the ingenuity and the technology. Now we just need the will to make it happen.
Well said.
After hearing about all these different CO2 capture technologies and things,
Yeah.
it's easy to get caught up in all the technical stuff.
Right.
But I think Professor Ghosh really brings it back to the bigger picture.
Absolutely. He's always reminding us that this is all about moving towards a more sustainable future.
Exactly. And he makes this really important point about renewable energy, like what it actually means.
Oh, yeah.
Because it's not just about having these like unlimited energy sources like solar and wind power.
Right.
He actually uses the term sustainable source.
Sustainable source. I like that.
Yeah, it really captures the idea perfectly because we could have like a zillion solar panels, but
if we're using more energy than they can generate, it's not really sustainable in the long run.
exactly. It's about finding that balance.
Right. Between our energy needs and what the planet can actually provide.
And Professor Ghosh also talks about this really cool concept, closed loop systems.
Closed loop. What's that?
It's like creating an energy system that's completely self-sustaining.
Oh, wow. Like a perpetual motion machine.
Well, not exactly perpetual motion, but the idea is that the byproducts of energy production can be used to like replenish the source.
Okay, I think I get it. So like no waste.
Exactly. It's all about closing the loop.
Does he give any examples of how this would work?
Oh, yeah. He talks about biomass energy,
Yeah.
burning plant matter to make energy.
Yeah.
And then you take the CO2 that's produced from that burning
Okay.
and you use it to grow more plants.
Oh, wow. So it's like a cycle.
It is. It's like mimicking nature's own carbon cycle.
That's so cool. It's like we're working with nature instead of against it.
It is. It's a beautiful idea.
It really is. And it gives me hope that we can actually create a more sustainable future.
Me too. And I think Professor Ghosh's lecture does a great job of highlighting both the challenges and the possibilities.
He doesn't sugarcoat anything, but he also doesn't leave us feeling hopeless.
Exactly. He really inspires us to think critically and to be part of the solution.
Well said.
This lecture has been such a journey. We've gone from the depths of the ocean to the heights of the atmosphere and everything in between.
It's mind-boggling how everything is connected.
I know. I always feel like these deep dives leave me with more questions than answers.
That's a good thing, right?
I think so.
Okay.
It means we're engaging with the material and thinking deeply about these issues.
Definitely. And it makes me want to learn more.
Well, if you're looking for more amazing insights from Professor Ghosh,
I am.
all of his lectures are up on YouTube. But for now, we'll leave you with this thought.
Okay, hit me.
If you could invest in developing just one of those CO2 capture technologies we talked about,
Ooh, good question.
which one would you choose and why? Think about the potential impact, how realistic it is, and, all the benefits that would come with it.
That's a tough one. I'm going to have to give that some serious thought.
Yeah, me too. But that's what these deep dives are all about, right? Getting us to think critically and creatively about the world around us.
Absolutely.
So until next time, stay curious, everyone.
Stay curious.